Hi, everyone. Welcome to the last talk of the day. Hopefully, you aren't too tired, but we'll be talking about scheduling policies in Yarn today. Quick introduction about who we are. My name is Varun. I work for Hortonworks, and this is my colleague, Wangda. Wangda is an Apache Hadoop PMC member. I am a committer on the Apache Hadoop project. Both of us have been primarily working on Yarn for a couple of years now. Primarily pretty much on all aspects, resource manager as well as the node manager. And the talk today is really kind of some of our learnings and what we would like to do in terms of scheduling going forward. Quick agenda for those of you in the room. Just a quick overview on the existing scheduling in Yarn today, how it's set up, what are the kind of things you can do. Then we're going to go on to adding support for more resource types, adding for something we call resource profiles, and as well as starting to go deeper into things like scheduling for services. Some of this stuff is, if you've seen the keynote demo or attended Vinod's talk earlier, you'll get an idea of where all this stuff is needed and where it fits into the bigger picture for overall. We also have a section on the GUTS API, the Grand Unified Theory of Scheduling. This is more, again, some future work about what we'd like to do going forward and how we feel the API, the actual scheduling APIs are going to evolve. And then Q&A at the end. OK. Quick overview of the existing scheduling in Yarn. Today, Yarn only has support for two resource types, memory and CPU. And essentially, in a lot of clusters, frankly speaking, people schedule basically only on memory. CPU is just a number that's passed and ignored. Yarn has this notion of a resource calculator that's used to do all the hard work when you actually decide where to place a container. And the default resource calculator, which ships, actually ignores CPU completely. And this actually led to some confusion where somebody posts on an email mail saying, my container wanted 4-week cores, but Yarn is kind of putting it on a node where it should not be running, and it's because the calculator is set up wrong. If you wanted to use CPU into account, you actually need to switch the calculator in the config files. And this is a bit of a problem when it comes to running large-scale applications. If the application is not aware of the resource types that are being used when scheduling, you end up in a situation where an application is releasing resources, assuming that it'll get containers in a particular manner, but that doesn't happen. So applications that are coded to run on Yarn actually need to start querying the resource manager to figure out what are the resource types being used when it's scheduling so it can make the right decisions. A good example of this is MR. In MapReduce, sometimes when it's kind of even MR actually starts spinning up reducers before the maps are finished. But if it decides that it needs to start killing some reducers to get back some more mappers, if it doesn't know what are the resource types that are being used for scheduling, then you end up in a situation where it's releasing containers but not getting back the ones it expects. There's no support for resources like GPU or disk or network. There are some patches in the community to add support for GPU, I think, but they're not entirely complete, and some work needs to be done. In terms of locality, applications can ask for host or rack locality. Again, if the request cannot be specified in a certain number of tries, we have a fallback into what's called off switch or star. Essentially, you'll give a container wherever you can. And it essentially tends to be the next node to heartbeat to the resource manager. This is good for MapReduce type applications where really you want to be close to the data, but if you're not that close to data, it's OK to get container elsewhere, but don't starve the application. This model doesn't translate well into services. In services, affinity and anti-affinity, for example, become a lot more important. If I'm running HBase, for example, I want to spread my region servers out. I really don't want 2 region servers running on the same machine. Similarly, for something like Zookeeper, you really want to spread out your Zookeeper nodes so that they're not running on the same machine. Something like Storm requires gang scheduling, where you really want to get all the containers at once, but don't get them piecemeal one at a time on various places. We also need support for things like fallback strategies. So a model would be if you can get me a container, for example, if you can Spark, which needs to talk to HBase, you want to be able to say, get me a container close to HBase region server, but if you can't get it in a few seconds or a minute or 2 minutes or whatever, fall back to another strategy where you say, OK, give me on the same rack or something like that. In terms of placement and capacity options, today we have support for node partitions. You can think of them as essentially something like subclusters. You can carve out a piece of the cluster for exclusive use or non-exclusive use, depending on the way you set it up. The primary use case really for this has been things like software licenses or GPUs, where you tend to have a small subset of nodes which have a particular attribute that really want to expose to the end user. Again, but this is a fairly big hammer. May not be as fine-grained as we need it to be to support the services use cases. We also support Reservation, which is something Microsoft contributed to the community. They essentially let you plan for capacity in advance, and this is really useful if you have really large ETL jobs that need to run, when at night, say, for example, and it's fairly predictable. So you can set up a reservation in advance and say, I need 60% of the cluster every day at 8 p.m. to 2 a.m., and Yarn will give you back a reservation token ID, and when you actually run the job, you can use that token ID, and essentially gives you some predictability in getting your containers. The flip side of this, if you don't have reservations, on the one day when your job is trying to run, if somebody submits an ad hoc job that takes up a lot of cluster capacity, your regular ETL job starts suffering. So reservations kind of help you alleviate with that problem. Okay, so let's talk about resource types and profiles. So one of the things we're really keen to do is add support for generalized resource types in Yarn. Clearly, CPU and memory address a bunch of use cases today, but I think GPU, for example, has been a wish list for a lot of people. A lot of folks want to be able to add disk and network as well. Once we add support for generalized resource types, we really want to be able to have admins use configuration to remove and add and remove resource types from the scheduler. This will also allow users to experiment with resource types. A good example of this is disk, even network, for example. When you ask people, when people say I want disk as a resource type, and you ask them, well, do you want disk IOPS or disk bandwidth? Immediately the conversation starts going to awkward directions. People really don't know until they try it out. And today, to try out a new resource type in Yarn requires you to go deep into the guts of the code and modify a bunch of very, very low-level classes. And the odd thing is, the next person to modify it will be making very, very similar changes. It's almost like boilerplate code. Essentially, everyone's just adding a new long or a new int with that same variable name change, which is being passed around everywhere, and then somebody's going and touching it. We hope to just kind of standardize a lot of this stuff so you can use configuration to add resource types and use configuration as the model. The current work that we are working on actually is mainly for countable resource types. So this is essentially where you can do math on the resource type. So you can say, I have 100 units of this resource type, this container needs 5. It is not for things like ports, which are exclusive. Essentially say, if I have this resource type, nobody else gets to use it. That's future work. We plan to get to it after we're done with the countable. The other thing we want to add is resource profiles. You can think of resource profiles as analogous to instance types on EC2. Adding more resource types leads to a flip problem where now users have to go modify all their jobs to submit the value for the new resource type. More importantly, I think, especially when it comes to, again, disk and network, I don't know too many people who know how much disk bandwidth or disk IOPS the jobs need. And this is a really, really hard problem for them to, question for them to answer. And it's something that honestly, they shouldn't even be worrying about. So what resource profiles lets you do is essentially collect a bunch of resource types into a profile. The profile is stored on the resource manager. And essentially, when the user submits a job, he just gives a profile name. The profile name can be like small, medium, large, whatever it is. And once you submit that profile name, you automatically inherit all the settings for the resource types that you need. What this means now is, if a user submits a job, is running with resource profile small, is unhappy, he can just go and upgrade it to a large or a medium and get the resources he needs, and doesn't need to start worrying about, is it my disk that's too low, is it my network that's too low, whatever. Just punch up a box, use a box mechanism, and just go up and down where you need. For those of you who are interested, Yarn 3926 is the umbrella Jira for the future. It actually covers both resource profiles and resource types, and is essentially about, let's say, there are some patches that have been committed to a branch. We're still working on it. And I'm not sure how readable this is, but anyway, this is an example of a resource profile. The one on the left, essentially, let's say just set up 3 profiles. There's a medium, a maximum, and a default. And the idea is that if a user doesn't specify anything, it's the default resource profile. In Yarn today, actually, if you don't specify how many resources you need, you actually end up getting the minimum. The problem there is today the minimum is also used as the increment when you're doing your calculations. And the default is a cleaner way of kind of separating that out. The one on the right has 6 profiles. There's a medium, a maximum, a small, medium, large, sorry, and default, and this thing as well. Once we have both of these in, Experimentation with resource types and adding support and removing resource types should be a lot easier. And we suspect that a lot of the use cases where people want to try experiment with different resource types can just be pushed onto an admin side of configuration as opposed to requiring hardcore code changes. Okay, from this point onwards, my colleague will take over. Right.
Okay. Thanks, Baron. So today I will talk about the first thing is the resource scheduling for services. Yeah, so the first thing I want to talk about is anti-affinity and affinity. For the anti-affinity, some services that don't want their daemons to run on the same host or rack to consider the fault recovery or the performance. So for example, in the below example, the service don't want the H-based region server runs on the same fault zone. So host 1 and host 2 in the fault zone 1, and host 3, host 4 in the fault zone 2. So we just want to run the H-based region server on one region server on one fault zone. And for the affinity, there are some services, for example, the Storm. They want their daemons runs too close to each other as much as possible, just for the better performance, especially for the network performance. So in the below example, you can see the two Storm water running on the host 1 and one Storm water on the host 2. So instead, comparing to if they Storm waters running in two different racks, they will get worse performance. And there are some requirements of the affinity and anti-affinity. The first is we should be able to specify the anti-affinity and affinity for the intra-application and inter-application. One example of the intra-application is just we talked about the region server and also the Storm waters. And for the intra-application, for example, we can run a spot job close to H-based region server for the better H-based read performance. The below is an example of the inter-application anti-affinity. So application 1 has two containers running on host 1 and one on host 2. So for the application 2, to achieve the anti-affinity to the application 1, it can only run on the host 3, which don't have any of the container running from application 1. And for the hard and soft affinity and anti-affinity, the hard affinity is to if the resource is not meet the requirement of affinity or anti-affinity, the scheduler will not assign the resource to the application. And for the soft anti-affinity, affinity is it's the best effort. So the scheduler will try best to allocate the resource meets the affinity and anti-affinity, but it can also allocate other nodes to the application. Just as the example below, the application 2, the hard anti-affinity is to allocate to host 2, but after wait some time, the scheduler can also allocate to the host 1. Yeah, so if you have interest, the YAR 1042 is an umbrella JIRA. And we can look at the demo for the affinity and anti-affinity.
Hello everyone, I'm Wang-Da-Tan. In the next moment, I will do a demo for anti-affinity and affinity prototype. This is a cluster for this demo. It has 10 nodes, and each node has 4 GB of memory available. In case you haven't seen this web UI before, this is a new YAR web UI under development. You may have already seen it in other presentations today. The first demo is self-anti-affinity, which means for the application itself, each of the node managers should only run at most one container from this application. Let's see this command. I'm going to use distributed shell for this demo. For people who may not use distributed shell before, it is a simple YAR application which run specified number of shell commands in the cluster. Let's look at the command line for this application. As you can see, we are using the distributed shell jar, and the command line is sleep. The parameter of the sleep is 10,000, so it will sleep for a long time. The number of container is 5, so including the application master container, this job will have 6 containers running in the cluster. The timeout will be very long, and it will submit to QA. This is a new parameter we added for this prototype. The operation is anti-affinity, so which means it will anti-affinity to its own containers. Let's run it. Yeah, so it is started running now. Let's go to the web UI to monitor this job. Click the application here. This is the resource usage for this application by node managers. Each bar is one node manager. The blue color is the resource used by this application. So as you can see, on each node manager, it has at most 1 running containers from this application. Then we will run the second application to affinity to the first application. This is its command. Similarly, this is a distributed shell program, which will run the same sleep job, but it will request for lots of containers. On every load manager in our cluster, it can only run at most 4 containers. So if there's no any restrictions, it should be able to take all the resources in the cluster. And its placement strategy is affinity, and the target is the first application. Let's copy the first application ID. Let's run command. Let's go back to the web UI and click the second application. As you can see, all the container from the second application runs on the same host, which already has a first application running. The 4 nodes, even if it has available resource, the second application will not get any container allocated on this node. The next example is anti-affinity between applications. So basically, we will run a third job, and the third job will only get allocated on the load managers, which is not used by the first job. So let's see the command line. We need to kill the second job first. Let's make sure the application is killed. Yeah, so the second application is killed, only has the first application running. And then we will run a third job. The operation will be anti-affinity, and the target is the first application. Yeah, it is started running now. Let's go back to the web UI to check the application. Let's click the application 3. As you can see, the application 3 allocated on the 4 nodes, which don't have the container from application 1 running. The 6th node is used by application 1. That's all my demo today. Thanks for watching.
Yeah, okay. Hope you like this demo. So I will continue. The next feature I will talk about is container residing. So currently, there are some services that wants to modify size of their running containers according to the workload changes. So for example, if the HBase region server finds the workload drops in some time, we can return some excessive resource back to the resource manager to improve the utilization. And the sequence will be the application master tell resource manager to change the container size. It will give the container ID and also the target size. And the resource manager will handle this request inside and change the resource, and then work with application master and load manager to update the container. Before we have this feature, application has to re-ask container with different size from yarn. And of course, since the application has to restart the container, the context in the test memory will be lost. The current status of this feature is it is an alpha feature, which will be included by Hadoop 2.8. And if you have interest, the YAR 1198 is an umbrella JIRA. Yeah, so the next I will talk about the GATS API. The GATS stands for Grand Unified Theory of Scheduling. I don't like this name. Yeah. So basically, currently, if you have used the YAR API before, the YAR API is not very easy to be understand, and it has some places that we're hard to add new features. We have some new requirements. Some of the following the requirements are already covered by Varun, so I will also go through of them. The first thing is the scheduling formats. So basically, we will try to do the allocate according to the plan A first. And if we cannot satisfy it in some time, we can fall back to the plan B. And currently, the YAR only supports one default scheduling fallback, which is first try to allocate to the node, then fall back to the rack, the last fall back to the off switch, which is implemented according to the delay scheduling. But user cannot change this behavior. Just like the example below, the application 1 wants to allocate on the host 1 and host 2, its most preferred host. And if they can, if scheduler cannot satisfy the host 1 and host 2, it can also accept host 3 and I think there is a typo. It's host 3 and host 4. Host 4 is the least preferred host. And also, the other requirement is affinity and anti-affinity. I already covered this in previous slides. The next is node partitions and node constraints, just like the example here. So the host 1 and host 2 belongs to the, first is the node partition. The node partition is a way we can divide a big cluster to several smaller clusters. So we can add different capacities to different queues in different partitions. And also we can add echoes to limit some partition can be only used by some specific queues. In the right example, the host 1 and host 2 belongs to the GPU partition. And host 3, host 4 belongs to we call the large memory partition, which has a larger memory than other nodes. And the host 5 is just the default partition. Differently, the node constraint is a way that we want to touch the nodes without complexities like the echoes and the capacity configurations. For example, the host 1 has a TAG is a Ubuntu, and it has a glibc 221 and JDK7, and some other nodes has different tags. So this one is not implemented yet, which is tracked by YAR 3409. And some other requirements. For example, the down scheduling gave me n containers at once or nothing. And the resource reservation, which is to give me the resource, to reserve the resource ahead of time. So just like data receive a token from resource manager and submit it later. This is supported by YAR 1051 since Hadoop 2 sits, what we need to do is to consider the unifying APIs. And also, we can think about to support combination of the above. For example, the down scheduling plus anti-affinity, which is to give me 10 containers at once to avoid the nodes which runs the application 5, for example. And also, for example, the scheduling 4 bytes plus the load partition tries to give me resource from partition A first. If I cannot get them in 5 minutes, any hosts are fine. Yeah, there are some problems of the existing resource request API in YAR. The biggest problem is it is not extensible enough. So for example, we cannot specify the relationships between resource requests. Currently, the resource request in YAR is grouped by priorities, and there's no connection between these resource requests. For example, I cannot say I want a resource satisfies both of the resource requests, or I cannot say I don't want this resource request. The second thing is the fragmentation of the resource request API. We have a couple of different requests to support different use cases. So for example, the resource request is what I want for now, and the blacklist request is what I don't want. The reservation request is what I want in the future. Sometimes the three requests cannot work with each other together. And also, if user wants to support different use cases, they have to add the different requests. So here is our proposal. We need to an unified API to specify resource requirement. The following things we want to consider. The first is allocation tag. So we're able to specify the tag of the containers. So after container is allocated, for example, the HBase region server container allocated, we are able to get this information from the resource manager. And we can specify the quantities of the request. For example, the total number of containers we want, and the minimum concurrency, which means give me at least n containers at once. This is for down scheduling. And also, for example, the maximum concurrency, which is don't give me more than n containers at once. This is to support the case that some application don't run too many tasks, which will slow down the backend storage system, like the HBase or HDFS. And also, we should be able to specify the relationships between the placement request. So, which is giving me resource request satisfied and or not of the requirement. And also, we want to specify the order of the 4 bytes. So, which is giving me request A first. If I cannot get A, 4 byte to request B, something like that. And also the time condition, which is to support the reservation. There will be resources between time 1 to time 2. So in simple, the application will, in the future, application can have the unified API to request for different constraint or conditions, and they can make combination of them. And this should be easier to be understand compared to the existing resource request API. And we can see some examples. The first example is down scheduling, which is I want 8 containers allocated to me at once. Each of the resource requests has an allocation ID, which is 1, 2, 3, 4, 5. And the application request, each container is 2 gigabytes. And the maximum allocation means the total containers I want. And minimum concurrency means give me 8 containers at once. The next example is reservation plus anti-affinity. So, which is to avoid the host which runs application 5, and it is in the future requirement. So the allocation size of each container is 1 GB, and I want 5 containers. The placement strategy means where I want to place my container. It is not to the target application ID, which is application the application 15. And the time condition is when I want the resource to be allocated to me. It is 10:50 p.m. Tomorrow or after. The next example is the request with 4 bytes, which is tries to allocate on the GPU partition first, then 4 bytes to any host. The allocation size is 2 GB for each container, and the maximum allocation is 10, which is my total containers required. The placement strategy is ordered OR, we call it. It is it means we can accept any of the two, but they have orders. The first, the most preferred placement is load partition, which is GPU. And if we cannot get GPU resource in 5 minutes, we can accept any host. Yeah, so here's currently the status and plan of this proposal. We are still working on the API definition to make sure first it covers all the target scenarios, and we are trying to make consensus on this API definition. And we will start the POC soon. This will be a placement of the existing resource request API, and the old API will be kept. And internally, we will convert the old API to the new request, so which we can make sure the old application will be less affected, will not be affected actually. So if you want to get more details, we have a pretty detailed design doc attached to ER 4902. Yeah. So questions? Yeah, thank you. That's all my presentation today. Yeah. So any? It's ER 4902.
Yes.
So I have a question about increasing the container size. Is that all the containers? Well, first of all, is that framework specific? I mean, is it specific to MapReduce or TES, or is it does it
no, it's not. So the question is the question is if the container size changing is application specific. It's not. So it's generally supported by ER scheduler.
Okay, and so when that negotiation happens and a container increases, is that for all the containers, or is that for in the application, or is that just for one specific container?
Yeah. So the question is if the container resizing is affected to one container or all the containers. The answer is it's affected to the container which is specified at the application. So the application master can specify arbitrary container ID and target resource to resizing.
Does the configuration then change? So like when you submit your application, you specify the size that you want your containers to be. Does the application keep track of that? And when you go look at the configuration later, does it reflect the size of the container changed?
So the actually, I'm not quite sure about this question. So do you mean if the application will keep the internal container ID, running container size, or not?
No, I mean like, well, for example, with a MapReduce job, you can go look at the configuration and say, how big were my containers for this MapReduce job, and if the application master is changing the size of containers, if I go look at that after the job is done, it'll still just say,
Yeah,
will
so
it still just say
okay,
I asked?
okay. Since so the question is if after the container is resized, can we check it in the other user interface like the web UI? So I think we can. So after it changed, we can get the updated resource from the scheduler. And if the application like the MapReduce wants to get their, for example, the application history server, the application itself needs to doing some work.
Yeah.
So the image, I guess my short question will be when you can we get this additional support like GPU type resource?
So
The reason I'm asking that sounds like suppose this presentation at the end is design something there becomes so complicated. Just wonder if you be ever going to get into that additional resources support.
So the additional resource type work is kind of unrelated to the Guts API side of things. So that ticket is actually going on. I don't know which release we plan to merge it in, but I suspect it's not too far away. I mean, it's on my list of priorities to do. So but it's not related to the Guts API. In case that's what you're wondering. The two are unrelated. The support for multiple resource types will come irrespective of whether the Guts API comes in or not. More importantly, we really want to move towards resource profiles as a way of specifying resource allocation sizes. We don't want people to anymore say, I want 2 gigs or 1 week. It's much easier for us to encapsulate that as a string, which is labeled later. It just makes things a lot more flexible for us.
Yeah, but the eager resource, the profile is interesting, but actually for certain applications.
Sure, yeah. Technically, even resource profiles and resource types are unrelated, and they're orthogonal, but not dependent on each other. That's absolutely correct. Like I said, they are, the Guts API and this are not related. We'll get it as soon as we can, and the community votes. That's it. Yeah, sorry, question.
Is there a notion of how long you require a resource for?
Time for resource. So there was a discussion in the community, I'm not sure where, figure the Jira number, about how to indicate long-running containers. And the discussion was essentially, do you ask a application master to essentially give you a time, or do you give it like a flag saying this is a long-running container and should be treated differently? I cannot recall the conclusion to that, but frankly, there is no decision either way. If you have some thoughts on what you prefer, we'd love to hear them in terms of, are you talking about like a hard deadline? Like,
I don't know how you do reservations without a notion of how long.
oh, sorry, for reservations, yeah, you do have a notion of how long you need the reservation for.
But don't you need it for everything else?
Sorry, in the sense?
To do a reservation, don't you need an idea of how long you have?
So when you do reservation, I think you give like a Manhattan you submit of the kind of the way your resource requirements go. And so you say, I need so many containers for this much time, and then so many containers for this much time, and then so many containers for this much time.
Sure. But don't you need to know how long everything else will be using the resources to properly do a reservation?
Yeah, so when trying to make the reservation, you have to specify how long this container will run, and the scheduler will kill these containers once if they are expired.
Yes.
So I just want to ask a question about this container resizing right now supports downsizing. Is that right?
Yeah, so the container resizing support both of the increase and the decrease. And for increase, it will go to the scheduler and wait for some time to get resource allocated. And for the downsize, it will immediately take effect.
Yes.
I'm very interested in disk IOPS limits. However, one way to actually express this may not be actually in IOPS because no one knows how many IOPS they do. However, we do know the minimum disk latency that we want the node manager to essentially preserve. Maybe if there was some way to include that in the design, it might be a good improvement for the system.
Yeah, so essentially that's one of the reasons we want to do resource types. We genuinely don't know for some things how to model them. So the idea is as long as you represent it as a long, which you can count up and down, forget the enforcement side of it. As long as you can represent the long up and down, you can just go in there, add it yourself, run a bunch of experiments, and figure out this is what works for me and this is how we want to go with it. And we really want to enable those kind of experiments or make them a lot easier. Yeah. Yeah, so the related to resource types are the isolation pieces. Essentially, when somebody says, give me 2 gigs, am I actually making sure that you don't go over the 2 gigs and stuff. Again, they're related. We do need to kind of make the isolation APIs a bit more flexible so people can plug in external isolators, isolation pieces, I guess you could call them, and how you want to isolate individual containers. Today, isolation essentially is something Yarn does and only Yarn does. Essentially, the node managers don't expose isolation features to an external plugin, for example, which could come in and say, I want to do latency this way, so ignore whatever else you have. Again, future work. Once we kind of get the types pieces sorted out, then we can get onto the isolation pieces. Yes. This person general is back, and then I'll get.
You mean convey Affinity one application to another?
No, types, like a edge-based or Spark kind of thing.
Edge-based to
Generalized edge-based.
Oh, okay. So we haven't think about this frankly, but I think because we since in our world the one single Yarn application, single Yarn cluster can run multiple edge-based applications, and also can run multiple Spark applications. We cannot Affinity one application to all the other edge-based region server, because sometimes you only want to read from a specific edge-based instance.
That would be where the anti-affinity case where you don't want to run your application if there's type X with type X.
Okay, so yeah, that's an interesting question. So currently, what we plan to support another thing is the Affinity to an application, to specific container type of an application. Yeah, but I think it's an interesting point if we can support, for example, the anti-affinity for all the edge-based instances. Yeah.
Yes.
Sorry.
Sorry, time. Yeah, sorry.
Okay, thank you.
Sorry about that.
No, that's okay.